Okay, so this is section 4 that we did of the Resonance Science Unified Field Theory thing module course thing. Yeah.
Yeah. So who else is taking it? Definitely leave some comments if you're taking that course and you're following through. How's it going for you?
So it's kind of like, what's the source of the energy that creates spin? And then it kind of goes again into like holograms and how they're made, which actually I liked that video. That was pretty cool. Like it showed like how, a hologram photo was made, like the different laser points. Did you see it?
Yeah. Funnily enough, I had actually watched that maybe about a month ago. Sabino and I were talking about holograms, and we sometimes we watch how things are made. So we watched that video before, and I was like, oh, that is super cool. It seems like it's so high tech. You need all that
right. And I feel like those were around when I was a little kid. So I'm kind of going like, I guess they must have known about those for a while, and those are cool, but yeah.
And how do they even figure out to do that with the two lights going? Anyway, like the two lights hitting that.
Yeah, it's a really cool
together.
It's a really cool little process. I actually kind of like that. And so I guess like I didn't realize that like hollow means the whole and the graph means image. So it's a whole image. So whole is present in every point.
Right.
So that's like, I always just thought hologram was just what it's called. Didn't know that there was meaning behind why they called it that. So that's cool.
Yeah.
And I like how I talked about like Mandelbrot fractals. And that a fractal is a pattern that repeats itself at all scales. That was a nice little definition for me of fractal, because like instinctually what it is, but it's nice to have it just sort of like, okay, defined out for you there.
Right. Yeah. I like, and this Nassim calls it the
fractographic. Yeah, I thought that's kind of cute.
Yeah.
That's cool. And then he goes into a bunch of like black holes are one of the most stable objects in the universe, and that basically protons are, in Nassim Haramein's theory, basically protons are nanoscaled black holes. Like they're like just like super little black holes. And the reason that the strong force isn't as strong is just because it's like ratio to its size, of the black hole, which is cool and stuff. It's just, I don't know, like I was even looking up, like we've never actually observed black holes.
Well, right, we just observe, you mean you're just observing like the results of them or what's around them?
I guess so. You're just kind of, I just feel like a lot of our understanding of black holes is still kind of theoretical. So it's kind of interesting to be like, all right, I'll take your theoretical theory and I'll add and I'll up the ante and I'll add another twist to it. And I'm just kind of going like, yeah, okay, maybe, cool.
Right. It's all conceptualized right now. Yeah.
Yeah. I mean, even there was a big focus in this one about how like the Planck or whatever is the smallest unit that we can measure currently. Yeah. And even in one of the videos, like Nassim says, like, does he think that's the smallest thing out there? No, it's just what, like right now in our instrumentation and like whatever, like that's the smallest we can go to. So it's like of this reality, that's the unit we're going with right now. Mm-hmm. Okay, but so then he puts a lot of significance on our observable universe is like the same number ratio as the Planck is small or something, but in like a positive versus a negative thing.
Yeah.
And I'm kind of going like, yeah, I guess, but they just even came up with how big the observable universe was like this year. So, I mean, that's always an ever changing, like, I don't even know if this thing has been updated since they've changed how big they think the observable universe is, and isn't that all based on essentially our instrumentation?
Yeah, but I think he mentions that point though. I think it's not like that's not overlooked. He says within our observable. So I suppose that number would change. Yeah. But would that matter really? Because then it would be to the something else degree negative.
Right. I mean, I guess his whole thing is like just saying that the entire universe is like every single proton. I guess one of his big theories is his unified field theory is that every single proton, which is this little black hole or whatever, is a hologram or a holofractogram. So it's like it has every little tiny proton has all the information of the entire universe, which is a pretty,
it has all the memory. Yeah.
Yeah, and that's a pretty big statement, but I mean, I think that's true. Yeah. At some point, you know, like, I mean, like that's how it would work. That's how it would work, right? I mean,
yeah. Yeah. Well, I don't know. I had some questions about what you said just reminded me of how he was talking with the fractals and said, so there's like the infinite is within the finite. So if you take a sphere or a circle, and even if it's a sphere, and then draw an equilateral triangle within it, and then break it down. I liked that visualization, and that's where the fractals come from. And then the infinite would be within this finite. So maybe the protons would be the finite, and then the infinite would be
yeah, I think he talked about how, like, even if you like with the Mandelbrot fractal, even if you started with these sets of numbers and then you go infinitely small or infinitely large out or whatever, you still are, there's still some sort of significance to where you're starting.
Yeah. Well, that was a question I had. First of all, what was this, if he took the sphere or the proton, I guess I'm just adding proton right now, but let's say the circle as a starting point, and he kind of compared it to the Big Bang, if that was it, and then that was the finite point, and then everything within that is infinite. I was still thinking, why wouldn't we be able to go beyond that? Like, why was that the finite point? Why was that the chosen point of reference, and why couldn't you go beyond that? That part I didn't understand. That was actually a question.
Well, because like towards the end, like it even like it was, this was in like 4.5.7. It was like the expansion of the universe could be directly, I can't read my own handwriting, something could be, I wish you could have written better, Nikki, to the evolution of a self-organizing surface which is necessary to accomplish this learning. And basically it's basically saying that instead of the typical one-shot Big Bang theory, he says that like this leads to the universe learning about itself through continuous model of the universe or something. So I guess they do kind of say that, like, actually there isn't like a Big Bang one beginning. This thing is always self-creating, which we kind of intuitively knew.
Sure. Yeah, exactly. But I still didn't understand, like, I don't remember what it was 4.2.4 when he explains infinity inside an infinite space. So infinity inside an infinite space, a finite space. Sorry, a finite space. Yeah. So again, I don't know.
Yeah, that is a weird concept, because
I can understand infinity, and it's right in that sense. But then, like, why would you choose this finite?
Yeah, space? Why limit it to the finite space, or like why does it have to be in that finite? So I guess because it's the hologram, because it can contain everything, and but then that is limited, isn't it? Like, I don't know. That's kind of like a chicken egg, like a chicken egg.
Well, I guess where science, I don't know, it kind of comes in where philosophy would come in, or contemplation, or theoreticizing, or anything, but really, I don't know. Are there actually scientific answers to that? I don't know.
And that's the thing. Like,
well, that's where I get hung up, because I'm not a math or science person. So I was like, yeah, it's a lot.
Well, and even when, I don't know, I kind of feel like sometimes, like, all the science and the math stuff is just, it's kind of like, this is a feeling, so it means probably nothing. But this happened to me after 9/11, when they always talked about, like, Al Qaeda and like all these different warring fractions or something in the Middle East, and weapons of mass destruction and all stuff. And I would read a news article and I'd be like, this is like Greek. This is like, I literally can be reading Greek. And like, I do kind of sometimes feel like it's just like, let's make this so super complicated so that everybody feels like it's above their head and they don't really know what's going on. But we're just picking like random stuff out of the ether to like, we're basing our number on this thing. This is how we're going to measure the speed of light, the constant speed of light. And then that's going to be, because we picked this arbitrary number that we're going to use for that, then we're going to be able to base all of the universe off of this one equation. They're like, oh, nope, your equation's wrong. Even in this one, he like tries to E equals mc squared. He's like, oh, but we can change that formula to E being the E of the proton, the energy of the proton equals, and then he like, tweaked a couple of extra things with the mc squared or something. And you're kind of going like, okay, because he was saying that mass increases with acceleration. So, mass is not a constant.
Right.
Which is actually, that makes sense, and so then whatever, but you're just kind of going like, am I gonna actually go in sometime and be like, oh, kind of, let's think E equals mc squared. Okay, I'm gonna start calculating stuff that then equals, I don't know, whatever I come up with, a flying car. I don't know. I don't really feel.
Do I have a flying car at the end?
Right. Like I kind of like, does it work in my practical 3D reality, or is it all just like we're theoretically playing around with each other on like, it's like a little video game, like, ooh, and I can do this formula. Really? I can do this one. I don't know.
Well, I could. I think that he tries to bring that point out a little bit in his own community when he said that. If you watch the video, I don't remember what section it was in, but when he was talking how he was at like a conference with colleagues, obviously, and he was and he brings up the question like the balloon, right? And who is this guy that's blowing this balloon? And all these like little things are stuck on the outside of this balloon, and everyone just looks at him like, oh no, you're just talking. Oh, you're starting to talk about God now, so we can't have that, or something that's beyond their explanation, which is important to talk about, because it's like, okay, well, if you're at what point do you have to bring into this factor like, well, who's causing this? What is actually causing this? Everything after that.
Yeah, and that is the whole notion of expertise, like in our society, where we give certain people expertise, which, not that they don't warrant it in some cases, but it also leads to other people fearing questioning things, because like, I'm not an expert on this, so I don't know.
Right. Well, I mean, here we are, you have more of a science background than I do, but here we are decided to take this course because we're interested in it, and because we think that, yeah, there's something to it. There is something to this whole, I don't know, holographic universe, or to the fractals, and as above as below. We just intuitively know that, or have just found it for ourselves in our own discoveries. So it's interesting to us, and so we are looking for that.
And it is kind of cool that it is putting some of that together in like a non-crazy way. Not that our way was crazy, but just like in a way that you could kind of even
read through it, or
kind of really spell out how it got to that. And then they do go in again a lot about how, bringing back the ether, and about how space is a unit and it's not empty at all, and that basically it's a vacuum full of energy, and that everything
comes
to contact with its electromagnetic fields repelling each other. So like all atoms are resisting merging, which I liked that visualization. And I was thinking like, oh, actually that makes a lot of sense, because it's basically like, if you think about your entire body as like all these little tiny atoms, and like instead of them like being one or merging into each other, they're all kind of like the opposite ends of the same ends of the magnet, like keeping each other like all into a space that you are. That, I think that's kind of beautiful, like visualization.
Right. Yeah. And well, go ahead.
Well, I was gonna say, and even he says that at absolute zero, there's still they think that everything slows down, and then like it just like ceases to exist or something. But then no, so like actually at absolute zero, there's still electromagnetic vibrations, which have even more massive energy. So that's cool. So that means that space.
Well then, but they said. The other thing was they couldn't even really get to absolute zero. So absolute zero is just, it's just right outside of, it's just right outside of absolute zero. So that's another.
And it's saying that space-time not only connects everything, it is everything. So, and like the ether, they call it the void, the energy, even the spirit or whatever. And like, I'm like, okay. And that has brought, like, we had talked about this in previous models, which they even talk about how it was really a shame when they removed the ether from science in general, because we're all kind of going like, wait, it can't be in nothing. And like we talked about our last roundtable discussion we had with our friends, is that like I was kind of like, does nothingness actually exist?
Right.
You know,
isn't nothingness something?
Yeah, because
yeah, exactly. Yeah, well, I liked the quantum entanglement, which isn't a new concept, but anyway, that's pretty cool. That goes back to how this really makes sense, because something that you're doing on this side of the world could actually have an effect, and they've proved that something has changed on the other side of the world. So that to me kind of just sums it up, like, oh, okay, well, if we've already proved that and we've seen that happen with twins or with like energy and protons and whatever, then
like they showed the example of the lightning right, basically, that like hit the satellite, but it was on the other side.
That was so cool. The satellite, really cool. Right, because you're like, wow, all this energy, you never really think about that, all this energy that's like lightning hitting the ground, but it's actually going out,
right? And it created, that was kind of weird, that it created antimatter like this. So like a particularly strong lightning strike created antimatter that went into like the stratosphere and then hit satellite and then went back. So, and they've seen that example like 4 times. I thought that was kind of interesting.
So did it go back because it hit the satellite?
That's I think I kind of felt like it went back because of the visualization of like the apple core, like of the stratosphere. So it was almost like it hit it and then it went back. I don't know.
It wasn't like it directly went back from the same position it came from.
Yeah, maybe not. It just went around the field and like, echoed back somehow. I don't know. But so, and I also thought it was really valuable for them to show us like, so like the proton is so small that like they gave you like a video of like ways to visualize that. But it was saying that if a proton was as big as a grain of sand, it would be basically inside the earth. Like that's
Isn't that crazy? I love that visualization.
So within an atom, like the proton is as small as 1 grain of sand is in the earth. So you're kind of going like, what? So that one was kind of like, oh, that helped me. And then the Planck is even smaller than that. Like, so who even knows? Which makes me whole other question go like, how have they ever measured this then? How have they ever measured a Planck?
That would be nice to know, just to know some of the equipment that's used and what kind of equipment is used. Is it electronic? Is it
right? Are you getting a visual sense of it, or is it like you're measuring it based on the reaction of something else around it? Or
right? Can you actually see?
That's the thing with I think it's the electron, right? They've never actually seen an electron. It's just either one of them. I don't know if it's the proton, neutron. I think it must be the electron. It's in theory. They just know.
Right. Because when you look at it, it moves, no?
Yeah.
It's never, you're only seeing it like peripherally kind of. Is that right?
Or I guess it's sort of like that's why I kind of thought the electron might have been like the internal or the atom's black hole, just because it can't be observed. It can only just like what you're observing is how things react around it or in relation to it. I don't know. I have to like go back and that's the thing with all these terms and definitions, like some of them just like don't stick in my brain. I have to like every time I think about the thing, I'm like, okay, like, wait, let me look up this thing. What does this thing look like?
True. But you're talking about terms that these are people with PhDs that have been studying it for decades of their life. And we're just like, all right, let's do a series. And some of these terms are new, I mean, I've kind of maybe heard Planck in passing, and then I was like, I had to go back and read it and look for other definitions for it to really kind of get it at the beginning. And then it was used throughout. So then the last few modules, so I was like, yeah, okay, now I get it. I mean, the last few sections of the module, but anyway, there's the terms. It's like, whoa. It's hard to speak about because we're not coming from that position.
Yeah, it is. And it's also, there was also some terms that I'm like, wait, I'll be like, wait, what? Like, see, here were some of my what questions. One, something it said something about like the total mass of all protons in the universe is like, I mean, they're all the same. So like the volume mass within each individual proton is equal. So I'm like, wait, what? How does that work then? Is it just the amount that collect that make a weight of something? Like,
well, that would make sense. Yeah.
Yeah, and then all is made of these little Planck vacuum oscillators that are collectively organizing. So like that's what matter is. And I'm kind of going like, okay, but then that kind of makes you go like, well, how does it decide what form to take? Like what, like, you know, like how does any individual, same thing with differentiation within cells, where it's like, how does these cells are just like, they are hologram in the terms of like, every cell in your body has the information, the DNA is imprinted in it, and it has all the information of your entire body. But like, how does this cell know to be a fingertip cell, and this cell know to be a nose cell, and this one an eyelash cell? Like how, like
exactly,
like even though all of them have all the information of the whole that is you, like how does it know which one to do at any time? And like I kind of wonder, like how does an atom know or decide if every proton is of equal mass?
I feel like it goes back to our consciousness conversation, or our communication between those things, and then consciousness, because that's true. How would it know?
Yeah, so it's like the more you know you don't know.
Yeah, right, exactly.
And I also I have a couple other notes, but like, yeah, I was kind of like, wait, lightning creates antimatter? What? Like, what is antimatter really again? Like, how does that work? And like, wait, what? How do they know it's antimatter?
I was like, oh no, antimatter. This came up last time. It's like, oh, no.
And I'm going like, how do they know it's antimatter? It looked like matter to me. It's like, I thought antimatter was the absence of matter, but then I don't know. So that one is to be looked upon into further.
Right. Yeah, because they left it there. Well, yeah, lightning.
They're just like, here's a cool video of lightning that shows you antimatter. You're like,
right. You're like, okay. Oh wait, and then antimatter was dropped after that. It wasn't talked about again. I was like, wait, can we got that? I thought the same thing. I was like, wait, I was happy that I was like, I don't think I can handle antimatter.
I'm already having enough trouble with the black holes. Don't put
right. Exactly. Yeah. Wait, there was something. Oh, this is just related to lightning, but I saw recently. It was recorded. Well, it made news now, but it was apparently maybe late 2018, maybe December. It was the longest lightning bolt ever recorded in the planet. It was over like 400 miles long.
Holy cow, 400 miles. That's like huge. That's
huge.
Where was it?
I think I want to say South America. Oh my gosh. I was going to send you the link and I don't know why I didn't. I was like, oh, it's kind of old news. I was like, it's from 2018. I mean, 2018. I know. I'll go find it. I sent it. No, it was a picture of it. It was a picture of it. I said, okay. I'll send it to you. We'll include it. But yeah. Anyway, that must have sent up a lot of antimatter, I wonder.
Yeah. Like I've always wanted to see a sprite, like the sprite is like, I don't know. I've heard different things where it's like it's where the lightning goes, like it hits down, but it also is such a powerful volt that it goes up as well into to the stratosphere, and it charges our electromagnetic, something in our atmosphere. It charges. So like it's actually very important. Like electrical storms are important for the health of the Earth, and that's kind of interesting to me because like, we can't regulate that like that. That's her own self-regulation. Like that's
that's pretty cool.
Yeah. So I always think that's weird when they want to mess with weather, like with these
absolutely
other programs. You're kind of going like, weather is kind of, it needs to be messed with. They're like,
I'll figure it out. Yeah.
Okay. So then it talks about how like the strong force isn't basically the strong force is actually gravity. Which is acting at a like super small level or whatever, and you're kind of. This reminded me of the electric theory, which is the electric universe theory, which is a whole other group of people who have their own ideas of how the universe is working, which is very cool. I like their. Actually, I'll send you some of these videos that they have. They're really cool. But this one guy named like Wall Thornton or something. He says that basically there's only, instead of four forces, like strong force, weak force, electromagnetic, and whatever, gravity or whatever. He says there's only one force in the world. We just are labeling it different things because it's acting in different ways based on like, you know, what its stimuli is, but it's all one force. And so I think that's kind of interesting that here we've never really completely totally understood gravity, and there's people who are starting to like debunk it in general. I think that's kind of interesting.
Mm-hmm. Yeah, I've heard a little bit about that with the debunking of gravity, but yeah, I don't know. But I think that I feel like in some ways that might still fall under unified field theory.
Yeah, well, I mean, we still have 2 more modules, so we'll see how it puts the forces and stuff all together. I mean, like this says like Nassim's big find is the source of the spin of the proton, which I was like, okay, cool. And maybe it was some of the math that I skipped over because I was like, like, I don't know, but I'm kind of thinking, all right, well, that's the big find. Like, how do you define that find? I don't know.
Yeah. I just wrote down one of his quotes. Everything has spin. Spin has to be included, and maybe some of the fundamental forces that create our reality. The force that produces spin is from changes in density.
Okay, cool. Yeah, I mean, and I watched a lot of like the tornado videos and stuff that they had in there, or they had like a couple of videos of the vortexes, like, or whatever, the going in the water. What do you call those?
Yeah.
Whirlpools.
Funnels. Yeah, I guess.
Funnel things. That's so weird. I wonder like where they're going. Like, you know, they just kind of.
Right. And then they dissipate kind of at the end.
Yeah, and they kept on bringing up how like the object, the mass increases when its acceleration nears the speed of light, and I like, that's cool. How did they figure? I mean, I guess they've measured that too. I would like to know how they measure that. That's cool. Oh, and then the other thing is that I have a plasma ball, like from when I was 8 years old. I still have it in my room. I love it. It doesn't work like it doesn't work like just always, but it has the one function that works on it is there's like a constant motion, and then there's a vibration motion. So when I turn it to the vibration motion, it still works. So like basically if I like make noise around it or tap the table it's on, or if I listen to music really loud, it like will start pumping with the music. So I'm like, yeah, it still works. It's cool. But I had never known that it could like light up light bulbs and stuff like that. I was like, ooh, I'm going to try that.
It reminded me of Tesla's stuff. I was wondering if some of his stuff came from that with Tesla with the light bulbs. But then I was thinking it still needed electricity, right? So that I was wondering, I was like, okay, so this plasma ball is plugged in, and then they're using those, you know, like mercury lights or whatever fluorescent lights. Yeah, to like light up this light. And that was cool. But I was like, there was still a source of electricity, right? Like,
yeah, I mean, because the plasma ball itself is plugged in. But yeah, but it's not. Yeah, I don't know. I'm going to try that though. I'm going to try my own experiment with my plasma ball, trying to light my fluorescent light bulbs. We'll see if that works. That would be cool.
Yeah. You should totally try it. And I also like the other thing with the penny on top, and like you can get
exactly. You get a little zap. I'm gonna try that too. I'm gonna be like, right. And they're like, you only get a little burn that'll last like a day. I'm like, worth it.
You know. All right, you try that.
Totally do that.
That's your experiment, Nikki.
Yeah, you did the Emoto that's right. Water experiment. I'm going to do the electrocution experiment, which, by the way, I've been electrocuted a couple times. It is not fun.
Well, what do you mean, like electrocuted?
Like I stuck a
here to tell about
knife
it, so what happened?
In a toaster in college because I was trying to get this bagel out. I'm an idiot, whatever.
What happened?
My hand went like this, and like my hand like got like I couldn't move it no matter what, and like I was like and like there was just like this jolts going up my leg, and it felt like it was horrible. And then what I ended up doing was intentionally falling back. Like that's the only way I could get my hand to like because your muscles like freeze, you can't do anything, and even my arm was so hurt. I was just like shaking. I mean, like it was bad.
Oh my God, that is so crazy. I can't believe that.
And then I plugged in something not too long ago. I plugged in like an Apple charger, like a iPhone charger into the wall, and it was like, and got like a thing.
Oh.
Yeah, in a hotel room.
I wonder why that happened. Were you wet? Like, why would that have happened?
I don't know. I don't even remember where I was. I wasn't wet, and neither was the charger. But it could have been like a lot of humidity, and I have no idea. They could have done some really weird, funky wiring in this hotel. I don't know,
maybe.
but it was
sounds like ungrounded wires.
Yeah, something went on, and I was like, geez. But yeah, because like I always used to like the feeling like when people would go down slides when I was a kid, I would touch them because I liked that shock feeling. Other kids would be like, ow, ow, and I'd be like, like, I mean, that was bad.
Oh, you mean like, oh yeah, like from static electricity?
Yeah, like when my siblings and stuff would go down the slide, I'd always touch them at the end, like to
right.
That static electricity.
Or like, yeah, I used to like rub my feet on the rug, like carpet, and do that.
Yeah, and I liked that feeling, like that little spark. I was like, ooh, I thought it felt cool, but like, no, being electrocuted does not feel cool.
No, oh my goodness, that sounds terrible.
Yeah. Oh, and then the last thing that he talked about that was the flower of life being the fundamental structure of the universe, which is cool. I like that, and I could see that within like how basically space isn't empty at all. It's basically all these little electromagnetic protons everywhere, and then the structure of them basically looks like the flower of life. That's really cool. I just hope that this doesn't all end up being a way for us to buy one of his crystal necklaces.
I don't know, but I want one of those crystal necklaces. So I hope that it's not, because I do want one. I've always wanted one. I think the prices have come down a bit, but anyway.
Well, it used to be like $1,000 or something.
Oh no, there's still there. I think I just saw one for $1,500, but I've seen like some of the top ones are like $49,000. Like they're ridiculously expensive.
Okay, well, I hope it's not some Scientology thing where it's like basically
like I bought this crystal.
Depending on the level of crystal that you buy, this is how you will know the unified field theory forever.
Right. Yeah, the space memory thing was pretty cool. And I just wrote here that reminds me of blockchain, and I'm like, I know nothing about either one of these things, but somehow it reminds me of blockchain. And the reason why it did was because according to blockchain, like all of these, like nothing is ever lost. Nothing can ever be rewritten. You can only add upon it. So this memory, this space memory, is like the same thing. It's never really lost.
So it can't be erased. Yeah,
it can't be erased. Nothing can be erased. That was the connection I had between that. And what else?
I actually didn't even know that about blockchain. So thank you for telling me that, because I was wondering how they were secure stuff. And then that makes more sense. So you can never erase like your record. Because my whole thing with crypto was always just like, yeah, but what if they just are like, oh, you did have $1 million? No, you didn't.
Yeah, no, they can't. That's the thing with blockchain. That's the joy of it. You can always follow the chain. For good or bad, I guess. But anyway, yeah. So the whole memory thing. So it's never like once something is, it's never not.
Yeah, I feel like that's how the Akashic records would.
Yes, right. And all of this, yeah. Just the final thing about this section was that I was looking forward to. I'm glad that it started going into the flower of light and the geometry and the geometry of, I guess, of space.
Yeah, the Fibonacci sequence and all that.
Yeah, all that. And I'm excited to see how that's going to play out, because I think it gets into depth more in the 5th and 6th unit. So stick around.
Yes, do indeed.
Join us back.
We're going to finish this course come hell or high water. So
yes.
All right, cool.
That sums that up. Cool.